let's perform a hypothesis test. So we test 98 lie detectors, and we show that there are 24 wrong results. All right, so we have a proportion here. Use a probability threshold of 5% to test the claim that lie detectors are correct less than 80% of the time. Do we have enough evidence to suggest to reject the null hypothesis? So let's focus on this claim. The claim is it's correct less than 80% of the time. But right now, I don't have a proportion of correct results out of all results. I have that there are 24 wrong results out of 98 total. But I can find the proportion of correct results by just taking 98 minus 24, right? Take the rest of them. So if I do that, 98 minus 24, that's the number of correct results. And if I put that on top of 98, that gives me what we'll call P sub S, or the proportion measured from the sample. That's the proportion measured from the sample of correct results from these lie detectors. And we find that that's about 0.755. So we want to find the probability, or rather, we want to test the claim that the proportion of correct results is less than 80%. So let's break up the claim into the alternative and null hypothesis. The claim is that the proportion of correct results is less than 0.8 or 80%. So the null hypothesis here is that it's equal to 0.8. The alternative is that it's less than 0.8. And I want to use a 5% probability threshold. So let's draw what that picture looks like. I have a normal distribution, and I'm going to center my normal distribution at the null hypothesis. So I'm going to center it at 0.8. Right? If I go into this blind, I'm thinking, okay, well, the proportion of correct results is 0.8. And from this sample, we measured 0.755, so a little bit less. So I want to put 5% of my probability in that tail. Right, because I want to use a 5% probability threshold that the true proportion is somewhere less than 0.8. So if I do that, let's look at that picture. What is the z-score that has 5% in the tail? So if I've got 5% in that tail, then that means by symmetry, I also have 5% in this tail, which means that I have 90% in the middle. So this z-score right there has 95% of the area to the left of it. So the critical z-score here is 1.645, meaning that on this side, it's minus 1.645. So if we find a z-score from our sample data lower than minus 1.645, it's inside that critical region, and we can reject the null hypothesis. That would be surprising enough. So let's find the z-score of 0.755. So the z-score is given to us by the data point minus the center over the standard deviation, right? That's the general equation. Now, because we're dealing with proportions, I'll take the data point, or the proportion that we measured from the sample, minus the expected value, or the center of the curve, right? The null hypothesis, divided by the standard deviation of proportions. And the standard deviation of proportions is P naught times 1 minus P naught over N inside of a square root, right? It's the exact same thing as when we were estimating proportions using sample data. That P naught right there and right there is always going to be the null hypothesis, or sorry, rather, it's always going to be where you choose to center your curve at. So here, our sample data was 0.755. The null hypothesis is 0.8. And those are all the pieces of the puzzle that I need to figure out this z-score. So in here, N was 98. We measured 98 total lie detectors. So when I do this, I find a z-score that is minus 1.11, roughly. So I have a z-score minus 1.11 That's not quite as far as minus 1.645. So I don't meet that 5% probability threshold, right? This isn't surprising enough. The probability of obtaining this score or that z-score has to be greater than 5% because it's not as far over as this minus 1.645 number that gave me 5%. So right now, immediately by just comparing the z-score that we got to the critical z-score, I know that this isn't surprising and that I can't reject the null hypothesis. But if you would like to see this done in a different way, you can use probabilities, right? You can find the probability of that proportion being less than 0.755. Right, so going back up to our picture, what is the probability in this tail? What is the probability of you obtaining that low of a success proportion, assuming that you centered your curve at 0.8? So in order to find this, let's draw that picture again. So it's the same picture and over again. I just have to shift it down. So there's 0.8. Here's 0.755. I want to find the area on the left side of that point. So I need to turn it into a z-score, but we've already done that. That z-score is minus 1.11. So the probability of having a z-score less than minus 1.11 from your table, you find that that's 0.1335 or 13.35%. So it is greater than 5%. So we would have been surprised at 5%. We didn't quite get there. So we cannot reject the null hypothesis. The proportion of, what is it? The proportion of correct lie detector results could be 0.8.